Hello everyone, my name is Anita Singh, your science teacher from Shri Rama Bharti Public School. Today I will explain few topics from time and motion. So let's start. Today we will discuss graphs and different types of graphs. Now what are graphs? First of all, the line graphs, where they are drawn. The line graphs are drawn on specially designed paper, and what this paper is known as? It is known as graph paper. The whole graph paper, if you have seen, the graph sheet is divided into squares of 1 centimeter size. And each side of each square is further subdivided into millimeters. I hope you all have seen the graph papers. The lines showing millimeters, you have seen they are marking are generally light in color. Now, what are the uses of graphs? Why we are using the graphs? First of all, a graphical plot can represent a large amount of data in a compact form. Second thing, a graphical plot makes the comparison of different sets of data easier. And one more is there, a graph can be used to obtain the value of one quantity for a specified value of the other. Now comes the presentation of data. All measurements give a lot of data. To use such data for analysis, it should be arranged in a suitable manner. Then it will be easy. So there are three types of graphs: the bar graph, the pie graph, the line graph. Now you can see this is a bar graph. This is a bar graph where it is between the runs made per over and the serial number of overs shown here. That is a bar graph. Second is a pie graph. Now you can see which type. This is a pie graph, and this pie graph is showing the daily requirements of some vitamins. And third is the line graph. The line graph, the graph drawn on an axis called line graph, right? A line graph is shown here. You can see it. And the distance time graph, which we discuss later on today, that is also a type of a line graph. The distance time graph is a line graph. Now, the data given in the table above. Now, you can see there a data is given here. Okay, so the data given in the table above can also presented as a line graph. As you can see, it is given here. Now it is given here, right? It is shown over here. A line graph is drawn by plotting the data into x-axis, and you can see the y-axis. The time is in the x-axis and the distance is given in the y-axis. If an object is stationary with respect to time, then we get a horizontal line, means the parallel to the time axis. And if an object is moving at a steady speed, it covers equal distances over equal intervals of time. Here, time increases to the right and distance increases steadily with times. And this is the condition of uniform speed. And the distance time graph for uniform motion gives a straight line. This you can see in this figure, in the diagram. The first one is showing that an object is stationary, right? You can see it is parallel. And in the second one, it is showing that this distance time graph, it is for the uniform motion. Now you can see the third one. It is little bit curved. If an object is moving with varying speed, different speeds, and it covers unequal distances in equal intervals of time, means the time increases to the right and distance increases unsteadily with time. And this is the condition of non-uniform speed. The distance time graph for a non-uniform motion is a curve. Now you can see all the three. This one shows that the object is stationary, and this one is showing that object moving with uniform speed, and the third condition, it is showing that object moving with non-uniform speed. So that is the distance time graph. I hope all the topics are clear. So it's time to say goodbye.